Hey guys, Mr. Duncan here just to give you a little bit more support on functions and function notation. The first practice, few of you were struggling, and the first few questions are just asking you, is this a function or is it not? So, how do you tell if something's a function or not? Well, first you have to know what a function is. So, a function is a special relationship where each input has a single output. A single output. That is the important part. Inputs are usually your x, are usually your independent variable. Independent variable. Your output, usually your y, usually your dependent variable. So every input, there is a single output, just one, no more. Single output. All right. So let's look at a few examples then. Gotta erase that. So here's a few tables. Are these functions or are they not? Well, what is a function? Each input has a single output. So here, x is your input. 3 has an output of 5. 3 has an output of -2. I can stop right there if I want, but 3 has an output of 1. 3 has an output of -3. These are all the very same input, and these are all different outputs. So this is not a function. Not a function. This one, 0, 4, 7, 6. These are all your inputs, 0, 4, 7, and 6. They all have an output of 1. Is that okay? The answer is yes, that is okay, because a function says that a single input can only have a single output. But these are all different inputs. And just because their output is the same is okay. That's fine, because these are all different inputs, so they still only have a single output because they're all different. Here, same thing. 2, 5, 8, 1. They're all different. They all have a single output. So there you go. How that looks on a graph. X. Well, where are your x's? Your x's are here. These are all your inputs, right? So how can I check if they have a single output or not? What is the output? The output's y. So if, say, 1, 2, 3, here's my input, right? This is my input. Then my output is my y. That's 1, 2, 2.5-ish. So that's a single input here. I don't have any other y value that goes for this x. Same here. Same here. But not the same here. If I choose, say, that looks like 3/4, I've got, let's change colors. I have this y value. I have this y value. I have this y value. That's 1, 2, 3 outputs for this one input, this x. So that is clearly not a function. Let's check here. These are your x's, right? Your x values. Let's say I pick this one. I've got one y value, one y value, one y value. Same here. All right? Just one. So this is a function. Doesn't matter that they're not connected. All that matters is that one x has one y. Here, 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 here. Again, these might even be the same. These look like they might be on the same line. They have the same output, the same y value. But that's fine because we're only worried about the x. The input has to have its own. So a nice way to check that on a graph is called the horizontal line test or the pencil test, because really what you're doing is you're making a horizontal line. You can use a pencil, hence pencil test. And you're going to grab it. Let me see if I can grab this. Going to grab it, and you're just going to move across. And if it touches more than one thing at a time, then you know it's not a function. In this case, it never does. So that one is a function. In this case, we're good, we're good, we're good, we're good. Oh, it touches more than one output here, so this is clearly not a function. Nice, easy way to see that. All right, there's checking if things are functions or not. Let's get rid of this. Now, for function notation. Function notation is just a different way of writing functions. So, let's look at that. This means this is the function f of x. So this here, this line, that is the function f of x. The function f in terms of your input x. This is not f times x. No, that's not right. It's not f times x. This is the function f of x. That means that is your input. This is your function, and this is the input. All right, so input, that's always x, hence why this is x here, right? F of x is your input. Okay, f of negative 4. Since this is f of x, this is only saying, instead of f of x, x is 4, or negative 4. So I'm going to go 1, 2, 3, negative 4 is x. But I'm talking about the function at negative 4. So at negative 4, my function is 1, 2, right here, right? F of negative 4 is 2. F of 0, that is where it's 0, right? X is 0 here. So boom, touching my y, my output is 0. F of 3, think about that. What do you think I'm going to do? That's right, this is my x. 1, 2, 3. Go down here. And whatever that is, that's like negative 1.8 or something, we'll say. Negative 1.8. F of negative 5, same thing. You're just going where x is negative 5. Right here. And y is 0 again. Again, this is still a function. You can try the horizontal line test. Everything has just 1. But what about when f of x is 0? That's different because it's not telling you the input. What is it telling you? It's telling me what it equals. What was this? This was your output. So the output is 0, right? Where is the output 0? Well, the output is 0 when y is 0, right? Because y is the output. Right there. Right? So that's when x equals 0. Is that my only time? No, it's not, because we already did these two, right? We already know that f of x is 0 at negative 5 as well, so 0 and negative 5. This is okay, because these are inputs, and 0 is the output. That's okay. You can have two inputs with the same output. You just can't have one input that has multiple outputs. I know I keep saying that, but that's the definition. That's what you need to know, all right? That is what you need to know. That's why I keep saying it. All right, let's erase. Erase, erase, erase. I need a bigger eraser. Okay. So, what's it look like with an equation? What's it look like with an equation? This says my function f of x is 2x minus 3. I could graph this just like we saw it on the graph. I could do that. That's fine. But this says the function f in terms of x is 2x minus 3. So all this is saying, f of negative 2, that means x is now negative 2. That's all it says. So what do you think we'll do here? 2 times x, but x is negative 2. So 2 times negative 2 minus 3. 2 times negative 2 is negative 4 minus 3 is negative 7. F of 7. Guess what? X is now 7. So same thing. 2 times x is 2 times 7 minus 3. 14 minus 3 is 11. Go ahead and try f of negative 4. I bet you can do it. That's right. 2 times -4 minus 3, -8 minus 3 is -11. Same thing here. K of x, that's fine. They want to call it the function k, that's fine. Don't worry about it. K of x, k of 0. So x is now 0. So -7 times x, which is 0 plus 1. That's 0 plus 1 is 1. So same thing. You get the idea. I'm being repetitive. Okay, why do we use this? Why do we use function notation? It's just a different way to use it, and it's also a quick way to write context. What is context? Context is meaning. Context is what do I mean? If you hear something says y equals 2x, what does that mean? But if I gave you context to that, that would it could be you get $2 for every homework assignment you finish from your parents. That'd be quite a deal. But then you would have context of what that equation actually means. So let's look at a few. Josh's group was selling suckers for a fundraiser. They sold them for 50 cents a piece, but they had to pay shipping of 30. I'm guessing that's dollars. The function for their sucker sales is P of S, again, not P times S, P of S, the function P with input S, is 50 cents times S minus 30. If they sold 150 suckers, how much money would they profit? So the point of calling this P of S is that this is the profit for your input, suckers, right? That's how many suckers. Input is the suckers. S. Profit function of S. So, in terms of 150 suckers, all I would say is my profit of 150 is 50 cents times how many suckers I sold, 150. So this is the same thing we were doing, right? 150 now. S is 150 now, so I'm just plugging it in. Minus 30, which would be 75, because it's half of 150, minus 30 equals 45. So that's what? $45. So if I write P of 150 equals 45, what does that mean? It's going to ask you that in one of the practices. What does this mean? P of 150 equals 45. Yeah, that's a lot of numbers. I want context. There's context here. Profit of selling 150 suckers is $45. That's what it means. That's the point of context. The profit of 150 suckers is $45. Okay, let's look at one more for that example. Not that example, different example of context. Lexi had her car towed when it broke down. It cost her $3.50 per mile to have it towed, plus a flat fee of $50. The function for her cost was C of M equals 350M plus 50. Why do you think they called it C of M? Read. Why do you think they called it C of M? Because it cost her this amount per mile. So this is the cost, the function of cost for your input of miles, right? So my cost in terms of how many miles I drove is 350. 350 times the amount of miles plus 50. right? So $32, right? $32. So, or 32 miles, sorry. So that's now m, right? That's the amount of miles. The function cost at 32 miles is going to be 350 times the amount of miles. Again, just plugging that in for m because that's what m is, plus 50, right? I'm not going to do this one in my head, so let me chalk that up in the calculator real quick. Times 32, 432 plus 50 is 482. 482. All right, what does that mean? I'm going to say C of 32 equals 482. What does that mean? In context. Pause the video and tell me what that means in context. Practice. Okay, C of 32. The cost for driving 32 miles is $482. The cost of driving 32 miles is $482. That's what it means. All right, if I were to ask you, what does CM equals, let's say, 64, 114 mean? What does C of M equals 114 mean? That means the cost for driving how many miles is going to be $114. Say I have $114 and you're wondering what the cost for driving that amount of miles would be, right? How many miles does it take to get to $114? So what I would do is say, okay, C of M is this equation here. That's C of M. So 350M plus 50 equals 114, right? This is C of M, and this is how many dollars I have. So you can subtract over the 50. And then you can, and then you can divide by 3.5. So 3.5 18.3-ish. It's about 18.3 miles. So again, how many miles can you drive with $114? Or how many miles can you get towed for 114 miles or dollars? That's about 18.3 miles. So again, you would say C of 18.3 is 114. The cost of being towed 18.3 miles is $114. All right, I hope that makes a little more sense for you. Sorry it took so long.